Okay, gang, I just wanted to give you one more quick tutorial on balancing equations like we did in class today, including the balancing marshmallows, which might be useful to those of you who aren't here for lab. How to balance chemical equations. We're going to start with the written form, and then we will do some balancing marshmallows, which gives you both a visual and tactile option if you're a hands-on kind of person. So your first step for balancing equations is to draw your bracket, which is done just like that. And then you're going to place the reactants and products on opposite sides of the bar. And just like always, you're going to put your reactants on left and products on the right. Now, when it comes to the next step for writing out the total number of atoms of each element on each side of the bar, you can do them all in a row. I showed you both ways in class, where you can just put them all straight up and down, or you can kind of separate them into columns based on the molecules you have present. Sometimes I find that easier, so I'm going to show you that way, but it is kind of up to you how you want to go about it. But you do want to work in the following order: metals, nonmetals, except for hydrogen and oxygen, and then hydrogen and oxygen last. So you're going to put in your iron, your carbon, and your oxygen on this side, including the number of atoms present. So Fe2 gives us 2 iron. C is all by himself, so we just have 1 carbon, and O3 gives us 3 oxygen. Do the same on the opposite side. We have Fe by himself, so that's just 1 iron. And then we have carbon, just 1, and oxygen, we have an O2. All right, so now what we have to do is see that we have the same number on both sides. So our first thing we're going to start with is our metal, iron, and we have 2 over here, but 1 over here, and that won't work. We're going to balance our metals, then the nonmetals, then the hydrogen and oxygen. Now, one thing to remember is that you can change the subscripts, these guys here, but you cannot change coefficients, which are the big numbers that go in front. We will have some of those in a minute. If you add a coefficient anywhere, you have to change the number of all the elements that it'll alter. So basically everything within the formula unit or molecule. So like we were saying, we have 2 and 1, that won't work. So we have to change this 1 to 2. And in order to do that, we have to put it up here. Now we cannot make it a subscript, it has to be a coefficient. Subscripts are going to change the identity of the substance, and coefficients are going to change the amount, and that's what we want to do. So now we have 2 iron. So we look and we say 2 iron, that looks good. And we move on to the next one. 1 carbon, yep, 1 carbon still looks good. Now let's look at our oxygen. We have 3, and then over here we have 2. That won't work. The easiest way to find the right number for balancing is to multiply the 2 numbers together. So if you multiply 2 times 3, you're going to get 6. And the same thing on this side, we're going to multiply the 3 times 2. So multiply the 2 times the 3 and you get 6. And then we're going to put that 3 right there, because once again, we can't make it a subscript. It has to be a coefficient. So then same thing here. We're going to multiply by the 2. We're going to get 6. So we're going to put the 2 right up there as a coefficient again. So now we have 6 oxygen, 2 triplets, there's 3 here, so 2 triplets is 6, and then over here we have 3 pairs, right? Okay, 6 and 6. But now what we have to do is we have to go all the way back. So after balancing your first nonmetal, go on and check to see that your metals are still balanced. If they aren't, repeat step 4. Gotta go all the way back. So we're going to go all the way back to the beginning, and we're going to look here. So we're starting here again with iron. Iron, we have 2. We have 2 of these molecules now. So now what do? Well, there's 4 because there's 2 pairs. So this has to become 4. Then when we come over here, we still only have 2, but we can't have 2, we have to have 4. So we're going to cross them out and make that 4, and then change this to 4. This is why it's good to work with pencil. So let's go back down to carbon. It's next. Okay, carbon, that's 1. All right, carbon, that's 1. Oh, it's not 1 anymore, is it? Because we had to give it a coefficient over here. There are now 3 carbon. So we have to Oh, yeah, iron was good. Sorry. So we got to get rid of that carbon and turn it into 3 carbons. And now we have 3 carbons. Well, that's perfect. But the problem is we don't have 3 over here. So we have to do the same thing here. And again, it's a coefficient. So now we're looking better. Yes, this looks good. So come back one more time and look at the bottom. Do we still have 6 oxygen? 2 times 3. 3 times 2, that looks good. So eyeball it one more time from the beginning. 2 times 2 is 4. That's correct. 4, 4, balanced. 3, that's 3. 3, that's balanced. 6, 2 times 3, and 6, 3 times 2. We did it. So now we know we're balanced, and this is what our final equation would look like. Now, if we're going to go on to balancing marshmallows like we did earlier today, if you'd like to use glue for your marshmallows, corn syrup works well. Today I had vanilla flavored corn syrup. I just happened upon it, didn't know it existed, and it sounded pretty cool to me. And if you don't have colored marshmallows, that's fine. Try Skittles, M&Ms, Fruit Loops, coins, colored beads, or even colored paper hole puncher dots. There's lots of things you can use. So we only had 4 colors of marshmallows. So what we did is we kind of changed what color represented what element, but we did try and repeat, if we repeated an element, we repeated that color. So here's how we're going to set this up. We have 3 oxygen, or oxygens are green. We have 3 pairs of oxygen. So we have 1, 2, and 3 pairs. And if you count them, you'll see there are 6. Then we have a carbon with 2 sulfur. There's a carbon and 2 sulfur. Over here we have a carbon and 2 oxygen. There's a carbon and 2 oxygen. And over here we have 2 sulfurs with 2 oxygen. So here's 1 sulfur with 2 oxygen. There's the second sulfur with 2 oxygen. So now what we want to do is count. 2, 4, 6. 2, 4, 6. Okay, good. Now, if you're going to do it the same pattern as before, so you should start with your metals, and then you could say the same thing here. You could say 2 sulfur and 2 sulfur. Okay, 1 carbon, and do oxygen last. Fine. 1, 2, 3 times 2 is 6. 1, 2, 3 times 2. And you'll see this the same amount, and it's balanced. And once it's balanced, you're happy, and you can move on to the next one. So 2 chlorine look like this. 1 sodium with 1 bromine. And on the other side of the bar, we have a sodium with a calcium and a second sodium with the calcium, because that's what our coefficient means. And then we have a pair of bromine over here. So what do we do? Let's start then with a metal. Find, pick sodium if you want. You got 1 here, you got 2, 3. You can do this chlorine here. There's lots of ways. As long as we're getting the numbers straight, that's what matters. So there's our sodium. We needed another one over here, didn't we? Because we had 1, we had 2. So we popped this guy down here. All right, cool. But if we're going to do that, remember that we're going to have to be making that as a coefficient, and that's going to change some things. So that means if he is paired up as a molecule, you have to bring down the bromine too, add another bromine too. So if you have one of these, you have to make a second one of these, okay? That's 2. There we go. So now let's count again. We got 2 and 2. That looks good. 1, 2, 1, 2, 1, 2, 1, 2. Hey, check it out. Very good. Moving on. We have iron, oxygen, 2 iron, and 3 oxygen. We have 3 carbon monoxide. There's 1, 2, and 3 carbon monoxides. And here we have 3 carbon dioxides. So we had carbon monoxide, now we're going to have carbon dioxide. There's 1, 2, 3, and 1 little lonely iron by himself. There he is. All right, so how do we deal with this? Well, let's see. If we add another iron, since we're starting with a metal here, we now have 2 iron here and 2 iron over here. That looks good. So that has to become a coefficient of 2. All right, great. Now let's see, how many carbon do we have? 1, 2, 3. All right, 1, 2, 3. Good. And how many oxygen do we have? 1, 2, 3. 1, 2, 3. So that's 6. And then 2, 4, 6. So that would tell us we are balanced. How about this one? Carbon and water. gives you carbon monoxide and hydrogen gas. So you have a carbon and a water and a carbon monoxide and hydrogen gas. Okay, so let's have a look. Carbon, 1, 1. Okay, good. Hydrogen, 2, 2. Oxygen, 1, 1. What does that tell us? We're balanced. Excellent. Next one. All right, this looks like a longer, more complicated one, but you're just going to need a lot of marshmallows. So 2 C's and 6 H's, but 2 sets of them. So there's 1 set, 2 carbon, 6 hydrogen, and the second set. And then over here are oxygen, 2 guys. There you go. Carbon monoxide again, 1 of them, and 6 water. So that's 2 hydrogens and 1 oxygen. Oops, sorry, didn't stick them on there. 2 hydrogens, 1 oxygen times 6. There we go. All right, now, what are we going to do? We have 12 hydrogens. We have 1, 2, 3. Well, look at these first. Look at these carbons. We got to deal with the carbons, right? So if we deal with the carbons, we're going to find that we're going to add 1. And remember, if it's going to be a coefficient, you have to change the whole molecule. So now we've started with 4. We've got 2. Let's see. That's 3. That's 4. All right, good. So here's our 3, 4, and 4. That looks good. All right, but here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 2, 4, 6, 8, 10, 12. That's looking good. The hydrogen looks good, but how about the oxygen? 2, 4, 6, 8, 10, 12, 14. What do we have here? We have 2. So we need, oh, sorry, we forgot to put our 4. I forgot to put that there. We're going to need 1, 2, 3, 4, 5, 6, because that's going to give us 2, 4, 6, 8, 10, 12, 14, which is what we need because we have 2, 4, 6, 8, 10, 12, 14, which this is going to be 7 pairs, right? 6 and 1, 7 pairs. And now you're balanced. Now, this one, we don't have a marshmallow for. You can use marshmallows, or you can just kind of watch the numbers like before. You got 1 silver, and here you have 1 sulfur and 2 hydrogen. Here you have 2 silvers, 1 sulfur, and then 2 hydrogen. So start with your silver. 1 here, 2 there. Well, we have to change that. And then we have to change that. So next you have your sulfur, 1, 1. Okay. Hydrogen, 2, 2. Looking pretty good. And you're balanced. We'll do 1 more of these. So cobalt and water. So there's your cobalt. There's your water. And here is your cobalt and oxygen plus your hydrogen. You can start with your cobalt. You have 1 and 2. Well, the 1 doesn't work. We have to get rid of that. Turn it into 2. There you go. Cobalt, cobalt. All right, looking good. Hydrogen, 2, 2. All right. Oxygen, 3, 1. So here's where we're going to run into a problem. That has to become 3, which means this has to become 3. So now we're going to go all the way back to the first step and go back and look at our cobalt again. Cobalt, 2. Okay, 2. 2. Okay, 2. Next was hydrogen. 2. Okay, oh, not 2. 3 times 2 is 6. And then over here, there's 2. So this isn't really 2. That has to become 6. And this, whoop, yeah, there we go. I should have crossed that out and made it a 6. I'm sorry. Imagine that's crossed out and there's a 6 so that you could get this one here. I think I just forgot to add that in. But there you go. That should be good enough to get you